Question number 46. Lithium and magnesium show diagonal relationship. Okay. Lithium nitrate decomposes upon heating to give a number of products. How many of these products are paramagnetic? Okay. So if we talk about the heating of lithium nitrate, students, the lithium nitrate upon heating, it forms the oxide along with the liberation of NO2 and O2. Okay. So if we talk about the paramagnetic species among these students, we know that NO2 is paramagnetic. It has an odd electron on nitrogen. And if we talk about O2, O2 is also paramagnetic. Students, both NO2 as well as O2 are paramagnetic. And students, for this question, we have to mark the correct answer as 02. Let us look at the next question now. Question number 47. In the extraction of Ag using the cyanide process, Ag is first converted into cyano complex of Ag plus and then it is reduced to Ag. The number of electrons gained by one atom of the oxidizing species and the number of electrons lost by one atom of the reducing species are X and Y respectively. The value of X into Y is. So we have Ag. It reacts with Cn minus in the presence of O2. There is a complex of silver cyanide is formed and this O2 is converted into OH minus. Okay. So what is happening is this Ag is first converted into Ag plus and then there is complexation of this Ag plus with the cyanide ions to give us this complex. Okay. So the electrons which is lost by Ag is gained by the oxygen and it converts into OH minus. Okay. So we have O converting into O2 minus. So there is a gain of 2 electrons by one atom of oxygen. So the value of X is equal to 2. Okay. Now it is further mentioned that the complex which is formed, it is reduced to Ag. So students, this AgCN whole twice positive is allowed to react with zinc. The reducing agent used over here is zinc and this zinc is converted into zinc 2 plus along with the formation of Ag. Okay. So what happens is, students, this electrons are gained by Ag and the electrons are lost by zinc. So zinc converts into zinc 2 plus and it loses 2 electrons. Okay. So the value of Y is also again equal to 2, students. So students, the value of X is 2, the value of Y is also 2. So for this question, we have to mark the correct answer as 04. Let us look at the next question now. Question number 48. The Ln3 plus ion. So the Ln represents the element of the lanthanide series. Having the least ionic radius has an atomic number equal to X. The value of X is. Students, if we talk about Ln plus 3, we know that the size, it decreases on moving from left to right. So students, the Ln3 plus ion which is going to have the least ionic radius has to be the last element of the series, which is lutetium. Okay, and the atomic number of lutetium is 71. So students, for question number 48, we have to mark the correct answer as 71. Let us look at the next question now. Question number 49. Consider an octahedral complex M, A, B, C, D and E, F, where A, B, C, D and E, F are simple asymmetric bidentate ligands. The total number of geometrical isomers possible for this complex is. So students, we know that this bidentate ligands, they cannot span the transposition. Okay. So these have to be attached at adjacent positions only. So A, B, C, D and E, F. So they have to be attached in this fashion. And now students, the linking can happen in 2 ways for every ligand. So this AB can be attached in 2 ways. This CD can also be attached in 2 ways. And this EF can also be attached in 2 ways. So total number of isomers is going to be 2 into 2 into 2, which is equal to 8, students. So for question number 49, we have to mark the correct answer as 08. Let us look at the last question for this paper, students. Question number 50. A metal M having D6 configuration forms octahedral complexes with 2 ligands L1 and L2. The strong field ligand L1 causes splitting equal to delta 1, while Weak field ligand causes splitting equal to delta 2. Ignoring the pairing energy, the magnitude of CFSE, which is the stabilization energy, of the complex ML16 and ML26 are respectively X delta 1 and Y delta 2. We have to report the value of the mod of 10 times X plus Y. So students, if we talk about this given system of metal and ligands, so we have ML1 whole 6. So the metal has a D6 configuration and the ligand L1 is strong field ligand. So students, if we talk about the configuration of these electrons, we're going to have T2G6 and we're going to have EG0. So there will be splitting and all the 6 electrons will be given to the T2G level and the EG level will have 0 electrons. Now if we talk about the energy, students, from the barycenter, the T2G level has an energy lesser than 0.4 delta 1 and this energy is greater than the energy of the barycenter by 0.6 delta 1. So the total crystal field stabilization energy in this case is equal to minus 2.4 delta 1, students. And now if we talk about the second complex, we have ML2 whole 6. So L2 is a weak field ligand. So in this case, students, the configuration will be T2G4 and EG2. So if we try and draw the energy diagram, the EG level will have 2 electrons, whereas the T2G level will have 4 electrons. Okay. So it is already mentioned to us that we have to ignore the pairing energy, which we did in the first case as well. So if we talk about the energy over here, students, so in this case, the total CFSE will come out to be equal to minus 0.4 delta 2. So if we look very carefully at the energies which are given to us, students, we can see that the value of X is equal to minus 2.4 and the value of Y is equal to minus 0.4. Okay. So the sum will come out to be minus 2.8. So if you talk about the value which is to be reported, it will come out to be 10 times the magnitude of 2.8, which will come out to be 28. So students, for question number 50, we have to mark the correct answer as 28. This is it for today, guys. I hope the solutions were clear to you. Thank you.